Hello friends, let's discuss the types of chlorination. So now depending upon the quantity of chlorine added and depending upon the stage at which the chlorine is added to the water and also on the results of chlorination, you have got these different types of chlorination. So plain, pre, post, double, breakpoint, super and dechlorination. So let's see each what it is. Now plain chlorination is a term which is used to indicate that only chlorine treatment is given and no other treatment is given to the water. That is, other treatment means sedimentation, coagulation, filtration, so nothing is done. Only chlorine is added to the water. Now here in plain chlorination, raw water is fed into the distribution system after giving chlorine treatment only. This helps in the removal of bacteria, organic matter and color from the raw water. This technique is used for treating relatively clean waters or relatively clearer waters having turbidities less than 20 to 30 mg per liter, and such low turbidity waters are usually obtained from lakes and reservoirs, because as you know, lakes and reservoir waters, they are stagnant water, so the flow movement is less, so turbidity has got chance to settle down. So usually compared to rivers, lakes and reservoirs are having lower turbidity. So such type of water which are relatively clearer, you can give only chlorine as a treatment and no other treatment may be required. So this is in this type of a case. And in other cases like during emergencies, when complete treatment cannot be given, then water supplies during war times for army troops, right, far away places where the army camps are there. So there also it is not possible to give complete treatment of water, then also you can go for plain chlorination. So while explaining about the disinfection, importance of disinfection, I have already mentioned when you cannot give complete treatment of water, at least chlorination is to be followed so that people who are consuming that water will not get any waterborne diseases. So in such cases also, wherever it is not possible to give complete treatment, you go for what is called as a plain chlorination. And the amount of dosage of chlorine which is added is about 0.5 mg per liter or even more than that. Now depending upon the quality of the water, you have to decide how many, what should be the dosage of the chlorine to be added when you are practicing plain chlorination. The next is the pre-chlorination. Pre means what? Before, right? Pre-chlorination is the process of applying chlorine to the water before the filtration or sometimes even before sedimentation. Now this helps in improving the coagulation and reduces the load on the filters. It also helps in reducing the taste, odor, in the control of algae and other microorganisms. Chlorine dose should be such that about 0.1 to 0.5, 0.1 to 0.5 mg per liter of residual chlorine comes to the filter plant, right? So the dose what you are selecting in pre-chlorination should be such that it is going to give a residual value of 0.1 to 0.5 mg per liter when it comes to the filter tank and when it comes to the filter plant. The normal dose required when you are practicing pre-chlorination is as high as 5 to 10 mg per liter. Pre-chlorination is always followed by post-chlorination for the final safety of the water, right? Pre-chlorination means you are doing it in the beginning itself, sometimes before sedimentation or sometimes before filtration. But when the water comes out of the filtration, you should always practice chlorination once again. That is what we call as a post-chlorination, so that there is a final safety of the water. Now next is post-chlorination. Post-chlorination is sometimes simply called as chlorination because this is the normal standard process of chlorination, which is applying the chlorine at the end. That means after completing the filtering operation, the last treatment unit provided is always a disinfecting unit, and this, as I have mentioned many times, the normal surface water treatment plant is always starting with sedimentation and ends with disinfection. So disinfection is the last unit. So chlorine is added in the end. Post is afterwards. So the pre is before, post is afterwards. So when complete treatment, all other treatment processes are over, in the end you are adding chlorine, therefore it is called as post chlorination. Now while treating normal public water supplies, when all other treatment have been completed, right, the post chlorination is adopted after filtration and before the water enters into the distribution system, right, before the water goes to the distribution system, we are adding chlorine. And as you all know, the regular or a standard residual chlorine value of about 0.1 to 0.2 mg per liter should be maintained, and therefore the dosage of chlorine in post chlorination should be such that a residual chlorine value of 0.1 to 0.2 mg per liter after a contact period of 10 to 20 minutes, right. So this residue, as you know, what for it is required, this residue will ensure the disinfection of water if it gets recontaminated again in the distribution system. So this helps in taking care of future contamination of the water. Then you have double chlorination. So as the name says, double means twice. So the term double chlorination is used to indicate that the water has been chlorinated twice. So whenever you are practicing pre-chlorination and post-chlorination, then it is double chlorination, right. So post-chlorination is generally, which is the method always used, while pre-chlorination is used when water is highly contaminated. So when you are expecting more contamination in the water, then for safety purpose, you are chlorinating the water twice. Once is in the beginning, before the water enters into the first unit. Another is when the water comes out of the filter tank. So twice. The second unit of chlorination plant required for pre-chlorination can also serve as a standby unit for emergencies. Right? Now this is another important thing which is called as a breakpoint chlorination. This also they can ask as a short note as a separate question. Right? Write a note on breakpoint chlorination. Right? Breakpoint chlorination is a term which gives us an idea of the extent of chlorine added to the water. Now there is one small graph here which you can see to explain what do you understand by breakpoint chlorination. So if they ask a short note, first thing is you are going to draw this graph. Now you can see here x-axis the applied chlorine value in terms of mg per liter, y-axis is the residual chlorine value in mg per liter, and there is one dotted line here exactly 45-degree angle, right. That means what? The applied chlorine value and the residual chlorine value, if they are equal, then you will get a line, straight line like this, which is exactly 45 degrees, right. Here what is written? Imaginary line which will appear when there is no chlorine consumption, that is for pure water. Can you see, whenever you are applying some amount of chlorine, I have explained this already in the earlier when I was explaining about residual chlorine. So when you apply chlorine to the water, it is going to do two things. One is to kill the microorganisms and another is to oxidize the organic matter. So for this purpose, some amount of chlorine is actually utilized, and after completing this work, if there is any extra chlorine left, then we call it as a residual chlorine. So this I have explained earlier, right. Now if suppose the water is completely pure, it is not containing any organic matter and it is not containing any organisms, then whatever amount of chlorine you are adding as applied chlorine will remain as it is, and after 10 minutes or 20 minutes if you test how much is the chlorine left in the water, you will find that whatever you have added, everything is left as it is, unutilized, because the water is pure. So in such cases, the applied chlorine value will be equal to the residual chlorine value. That is what is given here. When there is no chlorine consumption, so when the water is not consuming the chlorine, it is in a pure form, so applied chlorine will be equal to the residual chlorine. So but this doesn't happen in a regular water treatment, because the surface water is always contaminated. It will contain a lot of organisms, it will also contain some amount of organic matter, So when you are applying the chlorine to the water, some amount in the beginning, some amount of chlorine is used for killing the microorganisms. So this line, as you go on increasing the chlorine dosage, you will start getting some residual chlorine value, but it will not be equal to the applied chlorine value, because some quantity is going to be used for killing the microorganisms. So you go on increasing the chlorine dose, residual chlorine also goes on increasing, but it will be less than the applied chlorine value, and say point B is reached when suddenly there is a dip in the residual chlorine. So you will get a curve which is coming down like this. Now this is a point B where maximum amount of organic matter gets oxidized, and in this process of oxidation of the organic matter, lot of chlorine is used. Therefore the residual chlorine value will be very much less than the applied chlorine. Now there is a point C here, which is called as the break point, and from this point onwards you will get the residual chlorine line, which is exactly parallel to this dotted line shown here. Now what is the meaning? From this point onwards, whatever amount of chlorine you are applying, everything is going to come out as a residual chlorine value, because up to this point the chlorine demand is completely satisfied. Whatever chlorine is required by the water, everything is used up. All the organisms are killed, all the organic matter is oxidized. So beyond that point, whatever amount of chlorine you are going to add in the water, it will remain as it is. Therefore you will get a straight line exactly parallel to this line, which is, see here what is written, any addition of chlorine appearing equally as free residual chlorine. So whatever amount of chlorine you apply, everything is going to come as residue. So this point C is called as the break point. So this much you have to explain. Now in the normal chlorination process, it is a general practice to add chlorine beyond the break point to ensure a residual chlorine value of 0.2 to 0.3 mg per liter. So this is what we are doing in the treatment plant. How much amount of chlorine dose you are selecting, this again I have explained many times. The chlorine dose should be such that it is going to give a residual chlorine value of 0.1 or 0.2, maximum 0.3 mg per liter, right? So therefore break point chlorination you have to explain with a graph. Now this is another called as a super chlorination. This is a term which indicates the addition of excessive amount of chlorine. Super, that is the name, super, 5 to 15 mg per liter. Now you can imagine why we need super chlorination. Only in some special cases where highly polluted water, or during spread of some epidemic waterborne diseases in the area. In such cases, as a precautionary measure, you have to add more amount of chlorine, right? Now this excess amount of chlorine which you are adding in the super chlorination, they will be such that 1 to 2 mg per liter of residual chlorine beyond the break point is left in the water, which is not permitted, right? 1 to 2 mg per liter of residual chlorine will generally give a very strong medicine like smell in the water, and people will not like to drink that water, and that much amount of residue in the water is also not good for health. So therefore this is just as a precaution to kill the microorganisms we are adding, but later on you have to remove that excess amount of chlorine by dechlorinating agents. So you have to add some dechlorinating agent in the water, and you have to dechlorinate the water and again bring down the residual chlorine value to 0.1 to 0.2 mg per liter. Now last one is the dechlorination. As I mentioned here, dechlorination is the removal of chlorine from the water, and it is generally required when superchlorination is practiced. Now there are many dechlorinating agents which are used. You can see here sulfur dioxide gas, activated carbon, sodium thiosulfate, sodium metabisulfate, like that. So these are the different common dechlorinating agents which can be used for removing the excess amount of chlorine. So let's see the other things in the next video.